right, so we have been looking at atomic structures, specifically the parts of an atom. Well, yesterday we talked about isotopes, which is atoms of the same element but have different number of neutrons, therefore their mass will be different. Today we're going to actually look at more specifically the periodic table. So we're going to go to the bell ringer. So this is the 10th. So we're going to look at that. And beginning student view. We've got 5 questions to answer. Remember, this is extra credit, so you can potentially earn up to 5 points for this. So the atomic number, and so if you need to look back on notes, you can. What does the atomic number tell us?
Atomic number just tells us like what number.
Yes, the number on the periodic table, but what about the atom does it tell us?
I don't have that notes sheet. I think I did it on here. Sorry.
So is it electrons, protons, or neutrons?
I have no idea.
It is going to be protons. So atomic number always associate with protons. It is like the social security number of the atom. So atomic number, number of protons, that never changes for that particular element. Number 2, what does mass number tell you? What do we add together to get mass number?
The protons and the neutrons.
Protons and, I guess I should say sum of. How do you determine the number of neutrons an atom has? What 2 things do we subtract?
The mass number
Mass number.
and the number of protons.
And how do you determine the number of electrons an atom has? They're always the same as
The proton. Proton. Okay. I got it right on.
and as long as the atom is electrically neutral, they'll be the same. 5, how do you determine the number of protons an atom has? Look back at question number 1.
How do you? Oh, the atomic number plus.
Just the atomic number.
Okay, so it seems like I kind of know it, I guess.
Yeah, you just gotta know.
Can you just show me the answers real quick? Or, sorry, does it save it?
Well, this is protons.
Okay, protons. All right.
Sum of protons and neutrons.
Is that number 2? Okay.
Number 3, mass number minus protons.
Mass minus
Uh-huh.
protons. Okay.
4 is the same as protons.
Okay.
And then
5.
5 is atomic number.
Thank you.
All right, so what we're going to do is we're going to continue talking about the periodic table today. And if you have the paper copy I gave you, I You may want to have that out along with paper notes. If you're gonna do the paper notes, you can go ahead and submit a blank copy if you're gonna write on the paper notes. Or you can, type along in here as we go. Whichever you prefer.
For the period, table notes?
Yeah,
periodic
table notes. So if you're gonna fill it out on paper, go ahead and click submit here, and then we'll get started. Like I said, you may want your periodic table out as well. So again, just to review here, your periodic table is just a way to organize our elements that are known to exist. And notice that this goes up to 112, where your printed periodic table actually goes up to 118. So what happens at a certain point is we have a lot of man-made elements. And if you look on your printed copy, if it has a 3-letter code or symbol, they haven't named it yet. And so that's sort of the holding thing, the holding placement for it until they come up with a name. So a lot of these past, what is it, 108 are typically man-made. So they're going to be very unstable because they're not naturally occurring. And so typically on a periodic table, you're going to have some type of key that tells you what's going on. So on this one up here, we have a color code, so we know what all these different colors are. We have a key down here that tells us what's in the box, what each thing represents. And here tells you by the symbol color if it is solid, liquid, gas. Synthetic means man-made. Let's see if I said that right. Actually, it's from 93 on is man-made. So there's only 92 naturally occurring elements. So uranium stops with naturally occurring. Anything above that is man-made. And again, you can see on this one, this is an older periodic table. We had up to 114 on here. So it just depends on what periodic table you use. And I may have you label some things on here as we go through. And there's a color pencils there on your table you may want to use if I ask you to do. Sorry, that's
okay. I just get distracted.
The teachers are messaging. Let me.
It's all right.
And I have this on, so if I close out of this.
You got a lot of tabs open, huh?
Oh, yeah. When I work, I have my tabs.
I do the same thing.
I like to have them there. People give me a hard time.
Yeah, I put all my assignments up there. I have like 20 tablets sometimes. Yeah. It's okay.
All right, so on the periodic table, there's some terms you need to know. There are groups. Groups are your vertical columns, and vertical columns go up and down. So on your paper copy here, they are going to be labeled 1A, 2A, then you have 3B, 4B, all the way, and then you see a 1B and a 2B. Then it jumps back up to 3A to 8A. Now, on some periodic tables, these groups will start with number 1 and will go all the way to 18. So there's just different numberings, but the groups are the columns up and down. The elements in the same group have the same number of valence electrons. You need to know that. Group number, same number of valence electrons. These are the electrons in the outermost energy level, and it's what is going to be reacting or interacting to create new substances. So, in your notes, there should be a nice little chart. So group 1, so on yours, that would be 1A, has one valence electron. 2A has two valence electrons. We skip the middle section that has all the B's, and on yours it has 3A, but on some it's 13. It has 3 valence electrons, 4 valence, 5 valence, 6 valence, 7 valence, 8 valence. So that number is telling you the number of valence electrons. So because of this, they are going to have similar chemical properties. They're going to react similarly with other elements because of their valence electrons. So if on your periodic table, if you want to make a note that this top number tells you number of valence electrons.
Go ahead. I need to turn the log in. I tried to walk through what I knew.
But I don't have anything. Let me make sure I don't have anything set. Okay, and she's in my class.
She's trying to get in your class, but if you
Okay. All right,
put her in there, I got on the phone and I'll
all right. Can you transfer her down here? Or do I need to?
try.
If not, tell her to call back to 4520. That'll be the easiest. We need to leave. I can keep going. You got this? All right, so here's just sort of, if you want to label yours, you can. The easiest on here would be to just circle one of them, like that number, and just write out valence electrons on your periodic table if you wanted to.
Right.
Like circle the number 1 and just draw, the one at the top. 1A, right here, and do valence electrons.
Okay, I figured that.
And you don't have to label all of them, but
That looks
just a minus sign. So this number, 1, 2,
Sorry.
3, 4, 5, 6, 7, 8, these are going to be valence electrons. We don't do a lot with the middle section.
Okay, do you want me to just,
If you want to label each, you can, or you can say
I'll
1A,
just say B,
B, with the minus E, 1, 2.
like, I'll understand it.
So that would be, we don't do these in the middle here, do really weird things. So, all right, give me a minute. All right, hello. Maya? All right, are you in Canvas? You can't even get into Canvas? Oh, okay, what is it doing on Clever? Oh, I wonder, is your internet strong down at the bottom where you can see the Wi-Fi, how much Wi-Fi you have? Medium? Okay,
My thing kept messing up at home too.
what was it the other day that they had you do? All right, have you gone to where, you've cut your computer all the way off and you've had to log back in? Okay, when, I can't, hold on, can you get yours to the login screen? Like if you were gonna log, can you log yours out so I can see and step her through? If you can get to the
You want me to just
login,
turn it off?
yeah.
Or when it comes up to Clever?
I want to see how you log into your computer.
Okay. Yeah.
Because there's a way to have your
I'll
computer
just
forget.
sign out.
Yeah, sign out. All right, so if you go to sign out on your computer, now do you have to press something to get the, I thought it would just show up the, yes, if you know how to do that, remove your account. And now, do you have to restart after that, or you get that,
weird login. Log in that way and see if that fixes it.
You still,
You can log back in. If that doesn't fix the Clever, I have one other way where we can bypass Clever.
now mine isn't working. Oh, yeah.
So have you got logged in? Okay, instead of going to Clever, do you have on your bookmarks bar, do you have a SCS bookmarks? Or a student bookmarks or something? Click on that and just go straight to Canvas. See if there's an option for Canvas.
There it goes.
All right, it may be your internet. So what you can do, if you want to at least hear the lesson, I can give you my Google Voice number, and you can call that, and I can put you on speakerphone, and you can at least hear the lesson because we're just going over the notes. And we can do that. And while you are trying to get to see if that loads. So let me see if I can figure out how to find my number. Figure out. That memorized. Okay, so if I compose. Oh, well, here it's not going to show me. Shoot. Okay, so let me go here. And, oh, Gmail. And if I go down to compose. All right, if you call 704-389-0267, and I'll put you on speakerphone and you can at least hear the, what we talk about on the notes. Okay, 704-389-0267. All right, so I'm gonna hang up here and then I'll put you on speakerphone on that one. Okay. Bye. We're gonna get creative here. Okay, maybe that might, that starts beeping again, I'll come exit.
That's okay.
All right, so let's see if she'll call here. Okay, you hear us? Okay, so we're actually talking about the periodic table today. So if you have the paper copy of the periodic table, I don't know if you left it here or took it with that stack of work. That's what we're talking about. And we just mentioned that the groups are the columns. Those are the ones that go up and down on the periodic table. And on that paper one, they're labeled 1A, 2A, and in the middle, they have Bs with the numbers, and then it goes back to 3A all the way to 8A. we only deal with the A columns, and those numbers tell you valence electrons, and that's kind of where we left off here. And then some of these have names. So if you have your periodic table, I'm going to say some names, you can label them. 1A is called the alkali metals. So it's ALKALI metals. So if on your periodic table, if you wanted to label that first column that starts with hydrogen, and it has 1A, it would be alkali, ALKALI metals. These are the most reactive metals, and as you go down that group, they become more reactive, so it increases. This group doesn't include hydrogen. Hydrogen is not a metal, it's a gas. It is only on that side because it has one valence electron, and that's it. So it doesn't include hydrogen, so it is lithium through francium. 2A is the alkaline earth metals, ALKALINE, earth metals. So alkaline, ALKALINE, earth metals. They are the next reactive of the metals. You will see a lot of compounds with them and some non-metals. Group 3A, so skip the middle and go over to group 3A. These are the rare earth metals. And then in the middle, you have the B's, which on some periodic tables is 3 through 12. The middle section, we call that the transition. So on your periodic table, that's 3B all the way to 2B, because 1B and 2B are at the end. So that whole middle section is going to be the transition metals. And they do really weird things. They can have their number of valence electrons varies, so you can't use the group numbers for that. Then we're going to skip to group 17 or 7A. It starts with fluorine, and that is your halogens group. So 7A is your halogens, HALOGENS. These are your most reactive nonmetals. And for nonmetals, as you go down the group, reactivity gets less, so it decreases. And then the last group, 8A, or sometimes it's group 18, it is your noble gases, and they are non-reactive. They are chemically stable because they have 8 valence electrons. That makes them chemically stable. So here is one labeled. Groups that we didn't talk about. Sometimes group 3A we call the boron group. Sometimes 4A we call the carbon group. And 6A we call 5A we call the nitrogen group, and 6A we call the oxygen group. We didn't have a specific name that we just talked about, but a lot of times we use the first element for those because they have a variety of elements within that group. All right, the next thing on the periodic table are the horizontal rows. They are called periods. These elements have the same number of energy levels in their electron cloud. And we're going to do an activity where we actually draw some models of atoms. And to get the number of energy levels, you're going to need the periods. And there are 7. And on your periodic table, they're not numbered. So you may want to number, starting with hydrogen is 1, then lithium 2, sodium 3, potassium 4, rubidium 5, cesium 6, and francium 7. So there are 7 periods. And so that is going to be our number of energy levels. Now, sometimes you'll hear the term shell instead of energy level, but each energy level of shell holds a certain number of electrons. So level 1 will only hold 2 electrons. It's closest to the nucleus. And then you go one level out, it can hold up to 8 electrons. Level 3 holds up to 8 electrons for our purposes. If you take a more advanced chemistry class, you'll find that it actually can hold more. But for what we're doing, it holds 8. And then if we have a level 4, for our purposes, it can hold up to 18. So the numbers change for each level. Just remember, the closest to the nucleus is 2, and then pretty much 8, 8, and then usually we'll get as far as whatever's left over. We'll go in level 4. We'll never have it completely full. So this image here shows you the period numbers. So make sure if you want to label your periodic table, you can. Row 1, which has hydrogen and helium, is 1. Period 1, lithium. That starts row 2. Sodium starts row 3. Potassium row 4. Rubidium row 5. Cesium row 6. And francium row 7. The 2 at the bottom really fit in after barium and radium, but if we put it there, it stretches the periodic table where it will not fit on one page. So we're going to review a little bit of information from the periodic table. So what can we get from the periodic table about the atoms? So if we have magnesium, magnesium is actually in group 2. Mg is its symbol. We know that its atomic number is 12, so it has 12 protons. We look at the average atomic mass, and if we round that, it's 24, and we subtract 12, we get the neutrons as being 12. It's going to have 2 valence electrons in its outermost energy level because it is in group 2. The group number tells you the outermost electrons, which are valence electrons, and in this image they're colored red. It is in period 3, so we have 3 energy levels. 1, 2, 3, outside the nucleus. And if I go back here, notice that the first energy level has only 2 electrons. The second energy level has to have 8 if you have some on the third. So if I count all these circles, 1, 2, and 8 is 10, and the last 2 is 12, it should match the number of protons because we want electrons and protons to be equal. Also on the periodic table, and here is where if you want to use colored pencils and color your periodic table, you can. Metals, in the image I have up here, are shaded in blue. If you wanted to shade your periodic table, you would shade lithium down, beryllium down, you would shade the whole middle section. Then in 3A, you would shade aluminum down. In 4A, you would shade tin and lead. And in 5 and 6A, bismuth and polonium. And then the 2 rows that are by themselves, you would shade one color. That would be your metals. Metals tend to be shiny silver conductors of heat and electricity. They're malleable. That means they can be hammered into shapes or ductile, drawn into wires. And we tend to describe it as being left of the metalloid. So if it's left of the metalloids, metalloids are orange on here. There tend to be left of the metalloids. Now, some periodic tables will have polonium and astenine as metalloids, and some do not. So then nonmetals, if you wanted to color those on this image, they're purple. You would color hydrogen, which is actually on the left side, but it is only there because of its valence electron. You'd color it a color. And then you would color carbon in 4A. 5A, you would color nitrogen and phosphorus. 6A, oxygen, sulfur, and selenium. All of 7A and all of 8A. Those are your nonmetals. They tend to be gases, or if they are solid, they're going to be very dull and brittle. They're not going to want to conduct electricity, and we tend to say they are right of the metalloids except for hydrogen. Hydrogen's the only one that's on the left. Then we have the metalloids, and these are semiconductors. They can act like metals. They have physical properties like metals, but they tend to behave chemically like nonmetals. So those, if you wanted to color them, they're orange on this image. That would be boron, 3A. 4A is silicon and germanium. 5A is arsenic and antimony. And then 6A is tellurium, I can't say it right. And then, like I said, sometimes you would see polonium and astenine colored in. This particular image doesn't have them. But those physical properties like metals, but chemical properties like nonmetals.
I didn't get all of non-metals. I didn't get the last.
All right, let's go back just a minute.
Sorry.
No, that's fine. There we go. Now, I'm
I
going
got
to
it.
go through the last little bit on the notes, talks about an activity that I think we're going to do tomorrow in class. So I'll re-hit it again. But since it's on these notes, I will hit it right now. We're going to learn how to draw Bohr models. And these are simple diagrams that show the atomic structure of an atom. And so basically you see the nucleus and you see rings around the nucleus representing energy levels with electrons on each of those rings. And it kind of looks like the solar system model, even though we know that the electrons are not in a fixed position. They tend to spend most of their time in this area. And so we're going to look at actually how to draw these tomorrow, but you need to know the number of protons, and we get that from the atomic number. You have to determine the number of neutrons by subtracting on the periodic table the rounded average atomic mass, the decimal number, you round it, and that becomes the mass number. You subtract the atomic number to get the neutrons. You write the symbol and the number of protons and neutrons in a circle to represent the nucleus. And then you use the period number, that's 1 through 7, to determine how many number of rings you draw around the nucleus. And then you're going to put electrons on each level, filling from the inside out. So you're going to start with the ring right outside the nucleus, and it's going to hold 2. And say if you're trying to distribute 13 electrons, well, if you use 2, you know that you have 11 left. The next level can hold up to 8, so you put those 8. You've used a total of 10. So you have 1 left, and so you would have 1 on the outermost energy level. And then you would double check and make sure that whatever group that element is in, that matches the number of electrons you have in that outermost shell. That's the number of valence electrons. And we're going to do a practice tomorrow with that. So here are a couple examples. Here's nitrogen. Nitrogen has 2 electrons on the first level and 5 on the second. And that, I think, finishes our notes here.
And so what we are going to do, is if you've done the notes with us, then you'll submit that, or if it's on paper, we're gonna go back in modules. And I have one practice sheet that kind of covers, it says atomic structure. And this is going to cover using the periodic table, filling in a chart kind of like we did yesterday, except it's not dealing with isotopes. So it's going to use notes from today, and as well as how to do some calculations of finding protons, neutrons, electrons, and so forth. And there's also 2 videos. So once you have completed this, just make sure to go back and do the video and also work on that missing work. Have you had any luck yet with your computer, Amaya?
You're going in and out.
Oh, I'm sorry. It's because I don't have good signal on my cell phone, but that's the only thing I knew to use.